Assalamu alaikum. Now I would like to discuss about metabolic acidosis and how we can find the causes of metabolic acidosis. Okay, look at this stem first. In here, pH is low, below 7.4. Bicarbonate is low. Normal bicarbonate is 24. It is low, and PCO2 is 29. So pH is low, bicarbonate is low, looks like metabolic acidosis. Now I need to find out the anion gap. If you find a case with metabolic acidosis, then we need to find out the anion gap. Is it normal anion gap metabolic acidosis? It is high anion gap metabolic acidosis. It is nagma, or it is agma or hagma. Anion gap is calculated by 136 plus 136 minus chloride 92 plus bicarbonate. So 136 minus chloride 92 minus bicarbonate 14. So it is 30. So it is AGMA, or high anion gap metabolic acidosis. If you find a case with metabolic acidosis, it is high anion gap metabolic acidosis. Now we need to do the serum osmolar gap measurement. If we find a case with high anion gap metabolic acidosis, in here anion gap is more than 30. Now what we need? Now we need serum osmolar gap. Serum osmolar gap. How we can measure the serum osmolar gap? We osmolar gap. Say, so in here we can calculate measured osmolar gap minus calculated osmolar gap. So how can we can calculate the osmolar gap? Calculated osmolarity 2 into sodium plus glucose by 18 plus BUN by 2.8 plus ethanol by 4.6. So 2 into sodium, 2 into 136, 2 into sodium plus glucose, 2 into sodium plus glucose divided by 18 plus BUN, blood urea nitrogen divided by 2.8 plus ethanol divided by 4.6. So it is the calculated osmolarity. So measured osmolarity minus calculated osmolarity. If we find this, a high osmolar gap, a high osmolar gap is methanol and ethylene glycol. Methanol, the active form is formic acid, and ethanol, the active form is glycolic acid. Ethanol, the active form is glycolic acid. So methanol, the active form is formic acid. Ethanol, ethylene glycol, the active form is glycolic acid. So osmolar gap, high osmolar gap is me, and normal osmolar gap is ketoacidosis. In the mat pile mnemonic, the other rest of the cause, uremia, DKA, diabetic ketoacidosis, lactic acidosis, propylene glycol, isoniazide, salicylates, toluene, these are the cause of normal osmolar gap, anion gap, metabolic acidosis. And if we want to find the causes, if we want to find the causes of normal anion gap metabolic acidosis, so what we need to do, we need to do the urine anion gap. Urine anion gap is sodium minus sodium plus sodium plus potassium minus chloride. In this way we can find out the urine anion gap. So we need to do the urine, we need to find out the urine sodium, urine potassium minus chloride, and with this we can find out the cause. If urine anion gap is positive, if urine anion gap is positive, it is distal artery, or it is distal artery, that means type 1 artery and type 4 artery. And if urine anion gap is negative, then it is diarrhea, proximal artery like type 1 artery, and excess saline. So negative is negative is diarrhea and proximal artery and excess saline, and urine anion gap. Positive urine anion gap is distal artery, that is type 1 artery and type 4 artery. So, and how we can calculate the respiratory compensation, how we can calculate the respiratory, as it is a metabolic acidosis, we need to do the Winter's formula. And how we can do the Winter's formula, and a Winter's formula is 1.5 into bicarbonate, 1.5 into bicarbonate is 14 plus 8 plus minus 2. So plus 8 plus minus 2, so it is 29. So it is metabolic acidosis and there is respiratory compensation. So it is metabolic acidosis with appropriate respiratory compensation. And by this Winter's formula, we can get the compensation. And that is all about the metabolic acidosis and how we can evaluate the cause of the metabolic acidosis. It's a very high yield topic. Hope you enjoyed.